In this lesson, we're going to look at quartiles, interquartile ranges, and we're actually going to look at outliers too. So maybe go quartiles, interquartile range, and outliers. Now, all of this is makes sense. Will make sense because they're all essentially part of the same thing. Okay, so we want to arrange numbers in ascending order from lowest to highest. Find the 5-number summary by finding the median first. Okay. In the examples that we're going to look at today, we don't need to find all 5 numbers, but I'll talk about them anyway. And then find the interquartile range by using Q3 minus Q1, and we're going to talk about that really soon. And find any outliers using this system, which we'll talk about really soon too. All right, let's get into it. Make sure you write the title, learning goal, and date. Okay, so what we have here is a screenshot of the formula sheet that you'll find in any HSC maths course. So if you're doing maths in years 8, 9, or 10, this formula sheet will be given to you anyway because you'll see it at the end in the HSC if you choose to do maths. Now, let's talk about the interquartile range first. If we go back to what range is, not interquartile range, it's the highest number. So I'm going to write it here. Highest number minus the lowest number. The interquartile range is the highest quartile minus the lowest quartile. So in this case, it's the upper quartile, which we call quartile 3, minus the lower quartile, which is a quartile 1. So make sure you write that in your book, okay? Now that we have the interquartile range, to find an outlier of a score is that if we go Q1 minus 1.5 times the interquartile range, which is this number here, then it's an outlier, or more than Q3 plus 1.5 times IQR. Now this all just looks like a formula, so let's get into an example and see what it looks like. Okay, so what we need to do in this example is find the lower and upper quartiles. Now, the lower quartile has a name, and we've looked at it already, Q1. The upper quartile has a name, and it's called Q3. Okay, the first thing we need to do is arrange it in order. So it's almost in order. I can see there's a 4 here that needs to go in there, so I'm going to arrange it in order. 2, 2, 4 is the next biggest, 4 again. We've got 5, 6, 6, 7, and 8. So it was just that 4 out of place, okay? Now what we need to do is we need to first find the median. So I'm going to use a highlighter, and I'm going to go like this. Median is we cross one from the edge all the way down. And we look at this, and we have our median. Now, we'll go median is 5. Now, in terms of your 5-number summary, in terms of quartiles, it's called Q2. Q2 equals 5. All right. Now, because this is the case, I'm going to rub this highlighter off. Because 5 is the median, we can put lines around here. And what we're going to do is do this again. All right. I'm going to use a different color. So we'll go 1, 2, but just to this part of it. Now we have 2 middle numbers. When we've got 2 middle numbers, it's going to be the average of them. So Q3, the upper quartile, is going to be 6 plus 7 divided by 2, and that's going to be 6.5. So Q3 equals 6.5. So Q3 is the median of this set of data in the yellow, okay? All right. Now I'm going to have to do the same for the lower numbers. So I'm going to find the median of these ones, okay? Now we have 2 middle numbers. What do we do when there's 2 middle numbers? We add them together and halve them. So Q1, or the lower quartile, is 2 plus 4 divided by 2, and that equals 3. Now, many of you would have looked at these numbers and go, yeah, I know Q1 is 3 because that's the middle of 2 and 4, and you would be correct. And the same with 6 and 7. What's the middle of 6 and 7? 6.5. You would be correct. But sometimes we get two numbers like 12 and 31, and we're like, where's the middle of that? That's when we add them together and divide it by 2 and get a really nice number. Okay? Okay, so we've got those ones there. So he says, what is the lower and upper quartiles? So we go lower quartile Q1 is equal to 3. Upper quartile Q3 is 6.5. So that's the answer to A. Let's go with B. Determine the interquartile range. Now, the interquartile range is pretty straightforward. IQR is the upper quartile minus the lower quartile. Q3 in this case is 6.5. Q1 in this case is 3. So our answer, the interquartile range, is 3.5. And that's the end of this answer, and we're really happy about it. Okay, just a couple of things to think about. Okay, say I had 6 numbers, all right? So this is separate to the question. 1, 2, 3, 4, 5, 6. Now, I'll go about my business of trying to find the middle number. The middle number is between 3 and 4. It's right here. There. It's right there. And we'll find out that's 3.5. So that'll be the median, will be 3.5. Okay? What we do is see how in this one we put our lines from there to there, and then we started crossing off here. Here we've got our line in the middle. And so we start crossing off here. So what happens, it will have, this will be our Q3, and we cross out here, and this will be our Q1. Okay? So if you've got an even amount of numbers and an odd amount of numbers, here we've got an odd amount of numbers, we apply the techniques very similar, but just a little bit differently. If you're confused about that, please let your teacher know so we can sort that out. All right, let's look at this one. Using the following numbers, find the lower quartile and the upper quartile. The first thing I need to do is put things in order. Forget what the question is, I need to put things in order. Okay, so it looks like the lowest number is 2, so I'm going to start there. 2, then I've got a 4, 5, 6, 7, 8, 9, 10, 11, and 13, 14 it looks like. And then I've got 17, 22, 22, and 23. Okay, now notice I'm crossing the numbers off as I put them in. There's a very good reason for this, and that is that if I go back here and I haven't got something in the 23, I'm like, oh, I've got to put that into my data set. Okay, first thing I'm going to do is find the median. All right, so let's go. Now, here's the situation that I was just talking about in the last example. My median is here, all right? So median is, now we're going to go 8 plus 11, which is 19, divided by 2. So 18 divided by 2 is 9. So 9.5 will be our answer, which looks around the middle of that. Okay, so median is 9.5. Now that I've got my line here, I'm going to have to find the median of the upper numbers. So I'm going to use a different highlighter. And what I have is I have my Q3 will be in there. So Q3 is equal to 14 plus 17 divided by 2 because we've got two middle numbers. So 14 plus 17 is going to be 31, if I'm not mistaken. Yep, divided by 2. So 30 divided by 2 is 15, so it'd be 15.5. So Q3 equals 15.5. Now let's go to the second half. Here. We've got two middle numbers. Now this one's quite easily. I know that the middle of 5 and 6 is 5.5, so I'm not even going to calculate it. I'm going to say Q1 equals 5.5 because I can see that. Okay. So find the lower and upper quartiles. Well, let's go. Q1 equals 5.5. Q3 equals 9.5. Determine the interquartile range. So the interquartile range is, remember, the highest quartile minus the lowest quartile. So that is the highest quartile, it should be, I've actually written it wrong, 15.5, is 15.5 minus 5.5. So essentially, it's just going to be, the interquartile range will be 10, all right? Are there any outliers? Now, this is where we're going to look at this formula. Essentially, this is what I need to do, okay? And I'm gonna redo it over here. I'm going to do it in this space over here, okay? The interquartile range equals 10, okay? Now, what I need to do, if we look at our formula, I need to multiply it by 1.5. So 10 times 1.5 equals, so put that in your calculator. So go 10 times 1.5, and you should get, some of you have already done in your head, 15, okay? Now, to find any outliers, because it says, are there any outliers, and got to use calculations to justify, so this is C here. I'm going to have to go Q3 plus 15, okay? So our calculation that we've just done, we've done interquartile range times 1.5. And our Q3 in this case is 15.5 plus 15 equals 30.5, okay? Now what this says, if there's any number that's bigger than 34.5, there's an outlier. Is there a number that's bigger than 30.5? No. So there's no outliers on this end of the data, okay? Now, what I'm going to do is, what I'll do is I'm going to copy and paste it onto the next one because I'm running out of, so this is C, okay? So I've got C there. Now, I want to see if there's any outliers on the low side, so down this way of the data set. I want to see, for example, if 2 is an outlier, okay? So I need to work it out again. IQR times 1.5. My interquartile range was 10 times 1.5, and we found this calculation to be 15, okay? Now I'm going to go Q1 minus 15. What does that equal? Well, Q1 in this case was 5.5. So 5.5 minus 15 equals. So it looks like we don't have any outliers on either side. We're going to get minus 9.5. So is there any numbers that are less than 9.5? No, there isn't. We're still in the positive numbers of 2. Let me explain something. If I had an extra number that was 40, okay, that would be an outlier because it's bigger than 30.5, okay? And if I had a number that was negative 10, that would also be an outlier because it's less than negative 9.5. So be aware that you can use this formula right here to calculate outliers, all right? Interquartile range times 1.5, and then we add it or subtract it to our upper or lower quartiles accordingly. Anyway, that's the end of the lesson. Peace out.